Okay, so we welcome you back again for our second model of the medium length transmission line, that is pi model. And we want to do the same exercise, similar exercise that we have done for the T model. So what do we want? We want to find out the ABCD parameter. So ABCD parameter for medium length transmission line is the same. Transmission line. And this time it will be pi model. Sorry. This time it will be pi model. Okay, so in pi model, as we have done in the T model, is where I will divide my admittance parameter, that means capacitance parameter, shunt capacitance, into two equal parts. And then, so it will be like pi. So that means I will have the series impedance will be somewhere here, and I will have the shunt impedance on these two branch. So that means I will have the shunt admittance that will be divided into two equal parts. So this will be C by 2 of the whole transmission line. And the series impedance that will be remain total series impedance that will be in the middle. So I will have the XL and R, the total R of the transmission line, and total XL of the transmission line at the middle. So I will have this one is the capacitance. So similar to this one, it will be 2 by C by 2. That means Y by 2, and also this one would be Y by 2. This is XL, so that means this whole branch will become my Z. And I will have my load that will be connected at the end of this terminal, that is my ZL. And this one will be my receiving end voltage. And this is my receiving end current. And similarly, this one will be my sending end voltage. And this one will be my sending end current. So is for the voltage parameter, I have the circuit is simplified, but this current is divided. So I will have one current that is going through this branch that will be, let's say this is my IC2. And then these two current, IR and IC, will make this current is my I, let's say I. And then I will have IC1 here. And this I will make my current IS. So we have two nodes now. So we can use different colors. So we have node here. So we'll just. So we have node here and we have node here. So we can write this node as N1 and this node as N2. And fortunately, we have this voltage VR. We have these two are in parallel, so I can identify this is my VR. So I can just write down here, this is my VR. And similarly, VS, we can, because this is parallel to this one, so we can write down this voltage is actually here. So I will have Vs is here between these two terminals. So I have only one loop in this case. So I have only one loop of this one. With this one, I can identify my voltage relation. So we can just write down KVL in loop 1. So I can write down Vs is equal to I Z plus VR. Now here Z is equal to R plus JXL as it is, and Y is equal to minus JXC is equal to minus J 1 by omega C. So it's any way we can write down. So I have nothing to do here. We'll keep it as it is and mark it as equation 1. Then we'll work with this one because I have VR and this I has to be replaced with IR. Then I will have a relationship of VS with VS will be represented with IS, IR and VR. Now at node N1, we can write down the equation of relation KCL. So KCL will give me, KCL will give me IS equal to IC1 plus I. Okay, IC1 plus I. So IC1 I can write down equal to VS. So this is my supply voltage multiplied by Y by 2 plus I, and I can write down I in this case here would be IC by IC2 plus IR. So IC2 plus IR. So I is equal to IC2 plus IR at node 2. So then I can just write down Vs Y by 2 plus IC2 is VR Y by 2. VR Y by 2 plus IR, right? Okay. So from here, I have Vs that we need to change. And we can replace, now we can go back here from equation 1. So I can just write down Vs is equal to I can be written as IC2 plus IR that will be multiplied with Z plus VR. Now this one I can change to this equation, IC2 equal to VR Y by 2 plus IR Z plus VR, right? So I have IC2 is replaced with this one, yes. So now I think we have all the quantity is represented as VR and IR. So I can just write down VR YZ by 2 plus VR plus IRZ. So I can just take common 1 plus yz by 2 VR plus IRZ. So this is my VS. So as compared with VS equal to AVR plus BIR. So I can just write down A is equal to 1 plus YZ by 2, B equal to Z. So now what we can do, we can go back to this equation, equation 2, and now Vs can be replaced with this expression. So we can just write down, because Is has to be represented with. So from equation 2, we can write down Is is equal to, so we can just write down here 1 plus yz by 2 VR plus IRZ. That will be multiplied y by 2 plus VRY by 2 plus last one is IR. So now everything is replaced with VR, IR. So we will just bring all the VR together. So I will have 1 plus YZ by 2 VR Y by 2. Okay, so plus VR Y by 2 plus IR YZ by 2 plus IR. So then we can bring this Y, then this half would be equal to 1 plus YZ by 4 VR plus 1 plus YZ by 2 IR. Okay. Oh, I think this is correct. Yes. So I can just write down, this is, now we can compare with CD. Is equal to CVR plus DIR. So C would be equal to Y times 1 plus YZ by 4, and D would be equal to 1 plus YZ by 2. Okay, so this one is easy. Yes, easy. So let us just stop this recording.